Welcome to the deep dive. Okay, you've dropped quite the bombshell with these sources today. We're talking about a million-year-old fossil that's basically forcing a complete rethink of, well, us.
That's right. Our mission really is to dive into why this single crushed skull from China is, let's say, making waves, big waves.
Huge waves. And we're heading deep into the middle Pleistocene. You know, that period people sometimes call the muddle in the middle.
Affectionately, yes. Because it's been, well, confusing. We're looking at roughly 774,000 down to about 129,000 years ago. A really critical time.
Critical but messy. The fossil record's always been a bit ambiguous, hasn't it?
It has. And the fossil causing all the fuss now, Yunxian 2, found back in 1990 in central China, but it's only now, with new tech, that we're seeing its real significance.
And it completely messes with the old timeline, right? I mean, we thought the split between us, Homo sapiens, and Neanderthals was, what, maybe 600,000 years ago? Based on the genetic clock?
Pretty much, yeah. Around 500, maybe 600,000 years ago seemed about right. But Yunxian 2, it changes the calculation.
So what's the new number? How far back are we talking now?
Okay, so the analysis based on this reconstructed fossil and its place in the family tree points to the Homo sapiens branch, our branch, potentially originating over 1 million years ago. The estimate is around 1.02 million years.
Wow. Okay. That's massive, not just a small adjustment. We're adding almost 500,000 years to our own lineage's backstory.
It's a fundamental shift, pushing the origin of us back by, at least 400,000 years.
Mind-blowing. So for you listening, this means our family tree isn't just older. It's probably bushier, much more complex than the simple story we often hear.
Yeah.
But how? How do you get this level of detail from a fossil described as, well, crushed?
Right. Let's talk about the phoenix of paleoanthropology, as some are calling Yunxian 2. It was found in Hubei province, and honestly, it was in terrible condition. Compressed, distorted, geology wasn't kind to it.
I saw one description, geological pancake. That paints a picture. So early on, they couldn't really tell much.
Exactly. Calling it Homo erectus was the safe bet, maybe the only bet, because its true shape was basically hidden by all that damage. You can't be precise with the pancake.
So enter modern technology. This couldn't have happened without digital tools, could it?
Absolutely not. This needed a full digital restoration. We're talking high-resolution CT scanning to map every fragment, every crack, and then sophisticated computer modeling. There are really two key stages here.
Okay, walk us through it. How do you digitally unpancake something that old? Is it just an artistic interpretation?
Not at all. That's the crucial part. The first phase is called retrodeformation. Think of it like running the geological film backwards. Using algorithms, they carefully undo the effects of 1 million years of pressure, the shifting, the rotation, the scaling, even the plastic deformation of the bone itself.
So they're calculating how the rock pressure squashed it.
Yeah.
And then digitally reversing that specific force.
Precisely. It's incredibly detailed. And then comes phase 2, reconstruction. This is where they fill in the tiny fracture lines, carefully sculpt any small missing edges based on symmetry and known anatomy, and smooth it all out into a coherent cranium.
Okay, but how do we know they aren't just, nudging the digital bits to fit what they expect to see? That seems like a risk with digital tools.
That's the million-dollar question, isn't it? And this is where the transparency comes in. They often use software like Blender, which might sound odd as animation software.
Right, like for movies.
Exactly. But its Armature's feature lets them meticulously record every single tiny adjustment, every rotation, every scaling operation. It's like an audit trail for the reconstruction.
Ah, so anyone can check the work, see exactly how they moved each fragment.
Yes. It makes the whole process transparent and reproducible. If another researcher is skeptical, they can literally watch the step-by-step digital reconstruction. It moves it out of a black box and into open, verifiable science.
That's incredibly important. It means we can actually trust the result, not just take their word for it. So once Yunxian 2 was digitally resurrected, what did it look like? Who was it?
It wasn't Homo erectus, not in the classic sense. The features, once restored, showed strong similarities to the Homo longi lineage, the dragon man skull found in China. And critically, it also had features that seemed to link it to the very early Homo sapiens side of the family.
So the tech didn't just fix a skull, it revealed a completely different identity. A million-year-old member of a distinct group, not just another H. erectus.
Correct. And that discovery is what forces us to confront this deep divergence.
Right, back to the timeline shift.
Yeah.
Because if the Homo longi group, which Yunxian 2 is part of, was already around in Asia a million years ago.
And we know, genetically and anatomically, that our line, sapiens, and the Neanderthal line had already split off from that longi Denisovan branch.
They are split. The Neanderthal split. They must have happened even earlier, possibly much earlier than a million years ago. The common ancestor has to be older still.
Exactly. The origin point for all these large-brained humans gets pushed way back. The ancestor that eventually gave rise to all of us was walking the earth well over a million years ago.
Okay, let's try to map this out for everyone. The research now suggests we should think about 5 main groups, 5 clades of large-brained humans in the last, say, 800,000 years. Can you list them out for us?
Sure. It helps to group them a bit. So first, you've still got the classic Asian Homo erectus lineage. They were around for a long time.
Okay.
Second, the lineage in Europe that leads directly to Neanderthals. We'll call this the Homo neanderthalensis clade, even including its earlier forms.
Got it. 2.
Third, our own lineage, Homo sapiens, primarily developing in Africa according to the new model.
3. Makes sense.
Fourth, this newly spotlighted Asian group, the Homo longi clade, which includes the Denisovans and now Yunxian 2.
The focus of the new discovery. 4.
And fifth, this is where the cleanup happens. The group often just lumped into Homo heidelbergensis. We now need to be much more specific about who belongs where.
Okay, 5 groups. But the huge implication here is, if these distinct lines were already diverging around a million years ago, we should be finding fossils that look like proto-sapiens, proto-Neanderthals, proto-heidelbergensis from that incredibly early period.
That's the challenge, yes. They must exist. Either we haven't found them yet, or perhaps some fossils already in collections have been misidentified. We need to re-examine everything from that time frame with this new framework in mind.
Especially the Asian finds, it sounds like. Let's zoom in on that Homo longi group then. It's central to this whole story now, connecting Yunxian 2 and the famous Harbin skull.
That's right. The Harbin skull, the dragon man, was actually found way back in the 1930s, but wasn't really described and named Homo longi until 2021. And very recently, in 2025, according to these sources, further analysis confirmed its identity.
How did they confirm it? It didn't have preserved DNA initially, did it?
Not easily extractable DNA, no. But they managed to get mitochondrial DNA and, crucially, protein sequences proteomic analysis. And these confirmed the Harbin skull is Denisovan.
That's huge.
Yeah.
Because Denisovans were mostly known from, a finger bone, a few teeth. Now we have a full face.
Exactly. It finally gives us a proper look at what a Denisovan actually looked like, and it's quite a look.
Tell us about it. What are the key features of this Harbin Denisovan cranium?
Well, first off, it's massive. The brain size is estimated around 1,420 cubic centimeters, which is right up there with modern humans and Neanderthals. Very large brain.
Okay.
But the skull shape is really distinct. It's low and long, quite archaic in that sense. The forehead recedes quite sharply. The upper face is incredibly wide, and the eye sockets are large and almost square.
Wow. And there's something about the brow ridge.
Oh yeah, the brow ridge is enormous. It's actually the longest, most continuous brow ridge found on any hominin skull, archaic or modern. Just a very striking feature.
So a very robust, large-brained hominin adapted to, presumably, tough Eurasian environments. Now, geography. Yunxian in China, Harbin further north. And didn't you mention Homo antecessor in Spain being potentially related? That's 850,000 years ago.
Yes, the potential link to ancestor in Spain is part of this broader picture of an early, widespread Eurasian lineage distinct from what was happening in Africa. And the age of these fossils, Yunxian at 1 million years, ancestor at 850,000, really puts pressure on the traditional out-of-Africa model for our specific origins.
How so? Does it suggest maybe Homo sapiens didn't originate in Africa?
It forces us to consider alternatives. Maybe the common ancestor of sapiens, Neanderthals, and longi lived in Eurasia, or perhaps the divergence happened much earlier than we thought across both continents. The point is, finding such an ancient, distinct lineage like Homo longi firmly established in Asia 1 million years ago means we can't automatically assume Africa was the only cradle for the later stages of human evolution. The picture just got more complex.
We need to keep an open mind about where key evolutionary events happened. And the Denisovans, members of this longi clade, they certainly got around Asia.
Oh, absolutely. We have evidence of them from Siberia down to Tibet, maybe even Southeast Asia and Taiwan. It was a vast range over a huge period. And crucially, they met and interbred with modern humans migrating out of Africa later on.
Which is why their DNA lives on in us today, right?
Precisely. Populations in Melanesia, Aboriginal Australians, Filipino Negritos, some carry up to 5% Denisovan DNA. They are a very real part of the modern human genetic story, not just some extinct side branch.
Okay, so the Asian picture is getting clearer, albeit more ancient and complex. Now let's swing back to that muddle in the middle problem, the taxonomy mess, particularly around Homo heidelbergensis.
Yes, this has been a long-standing issue. There's a growing consensus among paleoanthropologists that two names in particular have caused more confusion than clarity: Homo heidelbergensis and Homo rhodesiensis.
Why get rid of them? They're in all the textbooks.
Because they've ended up as sort of wastebasket categories. Basically, for decades, if a Middle Pleistocene fossil wasn't obviously Homo erectus or clearly Neanderthal or clearly early sapiens, it often got dumped into heidelbergensis or rhodesiensis.
A catch-all bin.
Pretty much. And the result is that these species encompass fossils from different continents, different time periods, and probably different evolutionary trajectories. They obscure the real diversity rather than clarifying it. We need labels that reflect actual distinct lineages.
So if we're ditching the catch-all bin, what's the proposed replacement? How do we organize this crucial period now?
The key proposal is to introduce a new species name, Homo bodoensis.
Okay, Homo bodoensis. Where does that name come from?
It's named after a significant fossil, the Bodo 1 cranium, found in Ethiopia. It dates to around 600,000 years ago.
And wasn't that one found with tools?
Yes, associated with Acheulean tools, those classic teardrop-shaped hand axes. The strategic value of defining Homo bodoensis is its role. It's proposed as the direct ancestor of Homo sapiens, primarily an African lineage from the early Middle Pleistocene, though maybe extending into the Eastern Mediterranean.
Ah, so bodoensis becomes a specific ancestor for our line in Africa, replacing that vague heidelbergensis label for African fossils.
Exactly. It provides a clear anchor point for the sapiens lineage within Africa during that period, and this has knock-on effects for how we classify European fossils.
Right, because many European fossils were also called heidelbergensis. What happens to them now?
Well, take the famous fossils from Cima de los Huesos in Spain, the Pit of Bones. They're around 430,000 years old, maybe older. They were often labeled heidelbergensis.
But under this new system?
Under the new system, researchers argue they show clear derived features that link them directly to Neanderthals, things in the teeth, the face shape. They look like early Neanderthals.
So instead of putting them in the heidelbergensis bin,
the proposal is to reclassify them as early Homo neanderthalensis. They belong on the Neanderthal branch, not in some undefined ancestral pool.
okay, that makes sense. It cleans things up considerably. You have the African line, bodoensis to sapiens, the European line, early to late Neanderthalensis, and the Asian line, longi Denisovan.
Precisely. It reinforces that deep split we talked about, likely over 1 million years ago, between these major geographic and evolutionary trajectories. The Middle Pleistocene starts to look less like a muddle and more like a period of distinct regional evolution stemming from a much earlier common ancestor.
Let's pull this together for everyone listening, because it's a big shift. Basically, digitally rebuilding that one crushed skull in China, Yunxian 2.
Confirmed that the Asian Homo longi lineage was already distinct 1 million years ago. That finding cascaded through the timeline,
Forcing us to accept that our own sapiens line and the Neanderthal line must also be that old, pushing our origins back hundreds of thousands of years.
right? And that, in turn, forced a taxonomic cleanup. Introduce Homo bodoensis in Africa as our direct ancestor.
And reassign those European heidelbergensis fossils that look like early Neanderthals directly onto the Neanderthal branch.
Leaving us with a much clearer three-pronged geographic framework for recent human evolution. Africa leading to us, Europe leading to Neanderthals, and Asia with the Homo longi Denisovan group.
It's fascinating how technology, the ability to digitally reconstruct and share these fragile fossils, is solving problems that decades of just finding bones couldn't crack. It really changes the definition of us and where we came from. Much more diverse, much deeper roots.
Absolutely. Which leaves us with perhaps the most exciting question now. If we accept that Proto-Sapiens and Proto-Neanderthals were already separate lineages 1 million years ago,
And we have the physical proof for the Asian longi lineage from that time.
then where are their bones? Where are the million-year-old fossils that look like the ancestors of sapiens in Africa or the ancestors of Neanderthals in Europe?
They have to be out there somewhere.
They must be. So the big question now is, What kinds of geological deposits in which specific regions of Africa and Europe should we be targeting to find these crucial missing pieces? Finding those million-year-old proto-sapiens and proto-Neanderthals is the next major step to confirming this whole new picture, and maybe, just maybe, pinpointing where the ultimate common ancestor of all these lineages actually lived. The hunt is definitely on.